to swap the direction. For the EETs, the most common H bridge out there is the L298. Okay. In fact, we've got a ton of these L298s in the back room. I'll grab one for you real quick. Several real quick. For those of you that are doing projects, we actually have them already soldered onto small PCBs. Okay, so this is the L298. That's already on a heat sink and a little PCB. This is the 298 that, of course, you are welcome to develop your own board for. One of the issues that a lot of people fail to recognize is the fact that this is a power package. If you are drawing any kind of current at all with this, you're going to be dissipating a ton of heat, and if you don't heat sink this, then you're going to destroy it, okay? I have seen these catch on fire, okay? But seriously, I mean, they will catch on fire if you're not heat sinking them. This heat sink, in order to determine the the power dissipation factor, you have to go through and calculate the surface area and the thermal conduction factor for aluminum and determine how much heat it's actually capable of dissipating. So generally what you do is you just say, okay, well, cut off a chunk of aluminum, mount it, and hope it's enough. So, because we're electrical guys, not mechanical guys. So, well, you hire a mechanical guy to do the calculation for you. So you guys can take a look at those for you. The other configuration is what's known as a monopolar. Okay. Monopolar looks very similar. And by the way, keep in mind that this is a simplified drawing of stepper motor. There's a whole lot more going on inside of the stepper motor than just this. But in the case of a monopolar stepper motor, we're only allowing current to flow one direction. So what we have is a very similar circuit. You will have A1, A2, B1, B2, and then a common. Okay, these monopolars are they monopolar or unipolar? I think they're actually unipolar, so. Yeah, I see pyric acid now that it's on the board. Come in either 5 or 6 wire configurations. Okay. Why could we run it with either 5 or 6? Well, because there's 2 commons, right?
You just need one comment.
What's that?
Don't you just need one comment, or you can just...
Yeah, exactly. We can just get away with 1 common as long as we make sure to monitor the current capabilities of that 1 common, okay? The reason why this is called unipolar is because current always flows from the subsequent lead to the common terminal, okay? We never allow current to flow the wrong way in either of these halves of the coils, okay? Now, there's a very interesting thing that goes along with unipolar motors, okay? Any unipolar motor can be configured and operated as a bipolar by just not using the common terminal, okay? As long as the commons are isolated from each other. I better include that caveat. So in this case, we have a 6-wire motor. We know it's a unipolar motor. And for that reason, we could operate it in either the bipolar mode or the unipolar mode. The thing is though, is that if we're stuck with a bipolar stepper motor, we are only able to operate it as a bipolar stepper motor, okay? Now, what reason might we choose to operate a unipolar as a bipolar? Think about the distance here. Half the distance, half the field strength, half the torque.
So I have speed then.
So, well, not half speed, but half the holding torque that we'd run into here. So when you're working with these unipolars, if you choose to operate them in unipolar mode, you're going to be dealing with a degraded torque characteristic. If you want to operate it at the full torque characteristic, you need to switch over to the bipolar mode. Okay? So that pretty much runs us out of time. Any questions on this real quick?
Can you run either in either direction?
Yes, you can. Okay. All you have to do, in fact, the step sequence is exactly the same. It's just how you physically connect them that matters. Okay. If you want to run this thing backwards, I'll draw the timing diagram back up here. So we have A1, A2, A3, A4. So this particular step sequence will step it in one arbitrary direction. If you start with E2 and step through it backwards, it'll turn the shaft the other. If you want to hold the shaft in a fixed position, you just hold this signal on the line. Okay. From a controller point of view, there's no problem at all doing that. The problem becomes when you start dumping, well, what was the current specification on this? 5.5 amps. When you start dumping that 5.5 amps through your L298, that's when the challenge begins, because the controller can hold that state forever, but the power device that is expected to provide that current is eventually going to be destroyed if it's not rated properly. Good? Okay, so with that then, tomorrow we'll go in and start actually looking at the linear interpolation algorithm, and that should start getting you ready for the final programming assignment. So, good? I know one thinks that, oh, look at that, it died on me. Was it still coming over the microphone?
Yeah.
Huh.
Right
It said it was out of batteries, so. Oh well. So one of the things that EET students just don't get a chance to look at is stepper motors, and I know this last year Tim Bowe wanted to have a